Okay, we're going to write a different type of program using Turtle today. We've been using so far absolute coordinates, and I would really like to see the pictures that you've been drawing, preferably nicely coloured. With the holidays coming up, I'd like to see all of those handed in next week, and the work of this one in 2 weeks' time, because there are various various groups going to be hit by various holidays coming up. So you do have 2 weeks to complete this task. What you're going to do is you're going to draw some polygons. They're straight-sided shapes. We'll go through the mathematics in a few minutes, but we're going to use a couple of different commands. So I'm going to take you through drawing a square using these new commands, and they're forward, left or right. It depends which way you want to turn. So I'll just put up my tab, bring up the shell, I'll make it big enough to fit in your screens, and so we're not doing it very much. First of all, we'd still need to import Turtle. So I'm going to import Turtle, and like I did last time, I'm going to give myself a shortcut. So rather than saying Turtle every time, I'm going to say T. This is because I've got to use T so often. It will become quite obvious. T means turtle. I know I keep going on about people using short variable names. It depends how much you need to use them, and as nearly every command we're going to type involves using Turtle, it is appropriate to use a fairly short name. The first command we're going to do, let's just get a screen up, so clear, and I'll just make sure that's the right size for us as well. Yeah, if I do it like that, you should see everything I'm doing come on screen. So the first new command is forward. Now there are shortened versions of these, but for now I'm just going to stick to the long variable function names. So T forward 100, you'd probably guess, walks forward 100, drawing the line because I didn't use pen up or pen down. The next command is I can go right. I'm going to turn right 90, and if you look at the turtle, it's turned so that the direction he's facing has gone right or clockwise. So he was facing that way, and now it's turned to face this way. I know because the tail turns, sometimes it confuses people. I can go forward 100 again, and if I go left 90, I can create a staircase pattern, and I could keep doing forward left, forward right, forward left, forward right, forward left, and I could make a nice staircase pattern. Let's do the reset and go back to doing, say we're going to do a square. So the first command is to go forward 100. Second command is to go left 90. So I'm now going to draw a square going up, and I need to do this a few times. Forward 100, left 90, forward 100, left 90, forward 100, and I get my square. Now I've done 4 sides but only 3 turns. That means I'm not quite back to where I started. So let's do a left 90 to bring it back to facing the way it was to start with. That would allow us to then move and draw a square in another way. So if I do pen up and then say left 45, sorry, I need to put T in front of it, and say forward 200, from that point I can start doing a square. Now using the same commands though, the beauty with this is I don't have to change which, oh I forgot to do the pen down. There is a command backward, so I'm going to use it. That just makes it walk backwards. The reason I've done that is because I forgot to do the pen down. Boop. So put the pen down, and now I'm going to do the same forward 100 from the top, left 90, forward 100, left 90, forward 100, left 90, forward 100, and left 90 to make me point back in the same direction. Those two squares are supposed to be identical, and they will be the same size on the side, but it's a little bit heavyweight. I've done the same thing here. I've done forward, left, forward, left, forward, left, forward, left. I wanted to draw a square. I knew I wanted to draw a square. So I'm going to reset the screen, and I'm going to use a for loop to calculate my square. So just to be clear, start my program, I'm going to import turtle as t. Then I want to do, for a number of sides, so this is telling Python I'm going to draw the side of a shape. So for side, in range, how many sides do I need for a square? 4. So this is actually going to number them 0, 1, 2, 3. That's 4 places. So I'm going to use a shortened form to do 4 lines drawing me a square. It draws it quicker. It's a lot less typing. If I want to change the size of the square, I can change it more quickly, quite quickly. So all 4 loops should have a little comment in them. So my comment here is draw the side of a polygon. This consists of doing a forward 100, left 90, and then if I press an enter, it will go off and draw those 4 lines one after another. The reason this has advantages is if I want to change it, I can make it a bigger square just by changing the side. I could change the shape. Now I'm going to create an angle, and in a minute we're going to discuss. Let's go for 6 sides, so I want to draw a hexagon with a side 100, and for a hexagon I know I need to turn through 60 degrees. I'll talk in a minute about how I calculated that and which angle it is. So that's me drawing a hexagon. So I've now got a piece of code that will actually draw me a polygon. The thing that needs to change is this angle here, depending on how many sides. And we'll just go back to a whiteboard, and I'll talk to you about how that should work. So this is a little bit of maths. If I draw a polygon and look at what's happening, so I start here and I'm going along one side, and we'll start off drawing a square. I want to draw a square like that. Sorry, that one went the wrong way. So my first direction was I went this direction, and at the end of the line I was pointing that way. We turned through 90 degrees. Now what people don't realise is which angle is the turn. The turn is actually going from that arrowhead to that arrowhead. So it's the angle on the outside of the shape that we need. Come along here, I'm going up towards the top, and then I want to turn to face that way. So I'm turning through the angle on the outside. So we need the outside angle at each corner. And that outside angle has the name, an exterior angle in mathematics. Now I know as a maths teacher, Maths textbooks tend to focus more about the interior angle. In many practical situations, the exterior angle is actually more useful, particularly things like trying to navigate and give directions. You're talking about exterior angles for turning. And what also slightly surprises me as a maths teacher is you always get into the complexity of doing the angle on the inside. How big is that angle? Oh, it's 90 degrees on the inside. And I think that's more down to people can measure that angle quite easily. So the interior angle is on the inside, and I better colour code my text correctly, so that's red for the text. So my text for the exterior angle I'm going to make red. So the important one is the exterior angle, and the question is, how do you calculate it? Well, let's take a hypothetical shape. Don't worry about how many angles there are inside. I'm going to make it always concave, so it's always you're always turning in the same direction. Now, as you walk away and you zoom out, eventually this looks like a point. And as we walk round the shape, let's do this little red arrows. What we're doing is we're doing a series of little turns at each corner to change the direction we're moving in. Okay. So as we go around the shape, all these turns keep changing. Now if we put them all, merge them all together on this zoomed out version, my question becomes, what angle have I turned through going round the shape? Oops. So that one is going that way. This one goes that way. At this point I'm going that way. So the red arrows aren't showing a movement, they're just showing all the changes in directions we wanted. And then we got one big one that way. The question is, how far did I have to turn through in total? So starting off from here, I went through one full turn. So around the shape, we go through one full turn. Now, a full turn is 360 degrees. How many turns did I have to make? Well, on the square it was 4. Here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So the exterior angle is, if it's a regular shape, so for a regular angle, we're talking regular shapes, the exterior angle is 360 divided by the number of turns. So I can go back to my code, and if I decide I want a number of sides, and I will show you, we'll get this from the user and we'll run it a few times. So to get from the user, I need a number of sides, which is going to be an integer, from the user, so it's an input. How many sides do I want? Close the input, close the int. So it's going to pop up, how many sides do I want? I'm going to say the number of sides for this one, I want to draw 7. A number you're not going to be, actually let's do 5. You should actually know the exterior angle on those. We're going to calculate the exterior angle. And the exterior angle is 360 divided by the number of sides. So 360 divided by sides. Then my loop is the same. For side in range of sides. So this is, notice this is the plural. How many things do I want? I want the number of sides. The 4 is one of those sides. So it's a side. That's what the variables and using the English means. Draw the side of a polygon as a comment. I can then say t forward 100, and the turn, instead of it being the 60 degrees I knew for the hexagon, it is this exterior angle we've just calculated. So exterior angle. Put in a blank. We've said 5, so I should now get a pentagon. 5-sided shape. Where's my graph gone? Let's do a reset. Let's reset the screen and I'll get it to do the same. In fact, I should be writing this as a program, so let's create a program to do it. So it's a new file. The file I'm going to call file save as, and where's my Google Drive? Computer science. Here's 7, and I'm going to call it Python polygon. Py. Program title, draw polygon. And then I'm going to use the same commands I've just used. So I'm going to copy the number of sides. In fact, I'm going to show you a little trick for when you've done code here and you want to put it into a program. Now, that output sides I don't want at all, so I'm just going to remove it. And I know I also don't want these arrows and a space, and what I can do is I can do replace. So in edit, replace, I want to find 3 arrows and a space. I'm going to replace it with nothing. Oops, sorry. So I did 3 arrows with a space after them. I'm going to replace them with nothing, tell it to replace all, and now all my code has lined up properly. One thing I have missed, don't forget, we need to import turtle, and I keep referring to my turtle as T, so I need it as T. Save my program, Control S, or File Save. Now when I run it, I can do a polygon with 5 sides. Where's the screen gone? There, polygon with 5 sides. If I run it again, this polygon, let's draw 7 sides. Try running again. Just so we've got time to see it drawing, I'll do 15 this time. Yeah, 15 is a bit bigger than the board and it goes off and draws. So that's what I'd like you to try and do, is create me a program that will calculate the angles needed to draw the polygon, basically what I've just shown you. There is a template in the worksheet. That will give you a grade B if you can produce that code yourself. Well documented. If it's just a copy of what I've put in, don't expect me to give you better than a grade C. I want to see your own descriptions, your own variable names. Okay? So if you just copy my code and send that in, it's going to be put in as a C, because all you've done is, yes, you've issued a list of commands, but you haven't actually shown any understanding. You need to change the names of your variables to make them meaningful, change the comments so you know what's happening, and it's clear you know what you're doing. People in grade A, the sort of thing I would like you to try and do is something like the next pattern. So grade B, grade A students should really be trying to do a program that will produce a whole series of polygons, one on top of the other, A plus if you can get them to do different colours. I'll give you a little tip on that. If you want to do filled in ones with different colours, start with the big number and work down, because each time you draw a shape it will actually put more on top. So that's a good grade B. Grade A piece of work is being able to create this sort of pattern.